All right. Good afternoon, everyone. Or I guess almost good evening. Let's see, 24th. So we are, I believe we made it to chapter 2. All right, I believe we made it to chapter 2, and we are going to quickly review what we did and kind of pick up where we left off and try to finish chapter 2 today. All right, we were talking about Boolean logic last Wednesday. So what is Boolean logic? Just a quick recap. It's a type of algebra where the only two results you're allowed to have are true and false. That's it. There are two types of Boolean operators. You have relational operators and logical operators. I'll ask you what those words mean, but I will expect you to know how to use the various operators. But relational operators work with values, numeric quantities, quantitative values, and logical operators work with other Boolean values. So here is an example of some relational operators: right? Less than or greater to, greater than. An expression where you would use one of these operators should return true or false. We understand that in C, there is no such thing as true or false. That data type isn't supported. So C is going to return 1 or 0, which is the equivalent to true or false. Logical operators accept two Boolean values, well, 1 or 2, but they return something else based on the operator you're using. So if you have the two ampersand signs and the value to the left and the value to the right is both true, it would also return true. That would be the result of that expression. True and true equals true. Anything else is false. If either one of those is false, it's going to be false. Or is the opposite. If either one of those values is true, or is going to return true, and the exclamation point simply reverses whatever you give it. If you give it a true value, it's going to return false. If you give it a false value, it's going to return true. Very straightforward. We mentioned that if you wanted to, you could define your own data type called Boolean or called whatever you want it to be, and then you could use the word true or false, or you could include the standard Boolean library, and you could, again, define this data type, and you can use the word true and false instead of 1s or 0s or anything else. Basic arithmetic. So in C, we can do basic arithmetic: plus, minus, divide, multiplication. The percent sign stands for modulo. How many people are not familiar with the modulo operation? A couple of us. Okay, so think about a clock. So a clock has 1 through 12, but it never goes past 12, right? It goes back to 1, and then it goes to 12 and goes back to 1. So if I were to say, hey, I want to fast forward 26 hours from now, and it's 1 o'clock right now, it's not going to be 27 o'clock, right? If I were to fast forward 26 hours, it would be 3 o'clock. So that's kind of an example of what modulo does. Modulo takes one number, divides it by another, and it only gives you the remainder. So modulo gives you the remainder of a division operation. Yes. Oh, so I thought they had a question, sorry. So, but if you want to use these operations, you don't need any additional libraries. You can use these out of the box. They do follow the typical math order of operations, PEMDAS. There are a couple of differences. One big one is that in C, parentheses do not mean multiplication. Parentheses are only used for grouping in C. So parentheses do not mean multiplication. That means if I wanted to, and we'll just We'll do a simple one here. Print some numeric value, and we'll do 4 plus 3. Let's suppose that what I wanted to do in math, we would write it like that, right? 4 plus 3 is 7 times 2. That's what I want to do. So I want to display 14. If I try to compile this, I'll probably get an error. It doesn't know what that is. I expected a parentheses before this. It thinks that I've finished this statement already. If I want to do that, I need to add my multiplication sign. So there we go. So parentheses do not mean multiplication in C. They're only used for grouping. If I don't do this, right, what do we have? Then we have 4 plus, we're going to follow the normal precedence rules. We'll do this first. So it's going to be 6 plus 4, which is going to be 10 instead of 14, right? But we can use parentheses to group terms together, just like you can in math. So that's not different than math. But that's the only thing we would use. The parentheses are only for grouping in C. Now, sometimes you want to do math operations for doubles. What are doubles? Someone remind me what a double is. It's a data type. Decimal, that's right, decimal data type. So some kind of floating point number. Well, if you wanted to do that, there is a library that someone made called math.h. We'll just quickly go to it if you wanted to see. We're going to cover some of the functions in here today, but not all of them. There are many functions you can do: a cosine, a sine, a tan, sine, exponentiation, log of something, mod float. So mod is for whole numbers. If you want to use mod for floating point numbers, you would use this function that's in the math library. But you can see there are 21 functions defined in this file, and you could include remember what we said this does? This is a pre-processing directive that imports that library into our program, so we have permission to use those functions. Hopefully you remember what all those words mean, right? Library, collection of functions. What is a function? A named set of instructions. So standard IO, this is so I can print stuff. That's one of the things I can do with that library. And if we want to use those, functions that we just looked at in the math library, we would have to include this library, and then we could use those functions. So we could do something like printf long float. Recall we talked about format specifiers, right? So long float, that's the format specifier for a double. In between the percent and the format specifier, I put something here, 0.2, and if we were to look at the library, we would see that this means after the decimal places, that's how many spaces I want to print. I only want to print up to 2 digits after the decimal place. We could do more, but let's just do this for now. And we'll do pow, 2 raised to the 7th power. These are supposed to be doubles, but it's fine with whole numbers. It'll convert them for us. And what is 2 to the 7th power? 128, right? We could change this just so we can see it doesn't change the answer. Right, we just display more digits after the decimal place, more or less digits after the decimal place. Let me comment this out. Remember what we said about comments. Comments are not interpreted by the compiler. The compiler ignores comments. Who are comments for? Comments are for us. That's right, whoever's working with the file. That's what the comments are for. So we'll just comment this out so the compiler ignores it. And notice when I try to compile it now, what does it say? Well, let me clear this out. If I try to compile it now, you'll get this warning: implicit declaration of built-in function pow. That means, and you'll see this warning probably occasionally. This warning means that something hasn't been declared. So anytime you see implicit declaration of X, it means you're using something, but it hasn't been defined yet. I don't know what that is. In this case, I'm using the pow function, but I haven't given you a definition for that function. Someone else has written it. If I were to include that library, and they give you a suggestion here, that's nice. That's a nice new addition. They say, hey, if you want to, you might want to include this library. There's a function called pal.h in that library. Or you could write your own function. We'll learn about doing that later. But you notice now I can't use that because I did not import that collection of functions. There are also certain mathematical functions that are written for us in the standard library. And the standard library has more than just mathematical functions, but there are certain mathematical operations that don't have predefined operators like these up here. And if you want to use them, you can use this standard library. These are for whole numbers though. So if you want to do anything with floating point numbers, you would want to use math.h. If you want to do some stuff with whole numbers, you would want to use the standard library. And the ones we have here, absolute value, long absolute value. So these are for whole numbers. Who remembers the data types we gave for whole numbers? There's 3. I said there's only one that is important, but there are 3. Does anyone remember all 3? Or at least one? Int, there you go. That's the one we should remember. What are the other 2? Long. Short, very good. Short, long, and int. So L absolute value, this is if you want to perform absolute value on that long integers. And what is the difference? The only difference is that, short, int, or long are different sizes, right? They use a different number of bits to represent that numeric value. So obviously with long, that uses the largest amount of bits to represent a value, you can represent a larger number. Division, long division, etc. And let's do some examples. So here, I'm just going to copy this. I have let's close some of these. Say, oh, don't save that. I have a pre-made file, and we're just going to run through this and kind of look at this file and try to observe what's happening. And these are just examples of some of the things we've talked about today. So first of all, you can see that I've included the standard IO library. I need to print stuff. I've included the math library, so I can use some of those math functions that were created to work with floating point values. And I've also included the standard library so that I could use some of the math functions that were created to work with whole numbers. We have a couple of variables here, and we'll point a couple of things out while we're going through this. So here we have a variable declaration. We talked about that last week, right? I have a data type, I have a variable name, and I have a value. So I'm initializing, I'm declaring, this is my declaration, I'm saying it exists, and I'm giving it a name and a data type. And initializing it, I'm just giving it an initial value. It's pretty intuitive. On the same line. So you can do that in C. Here I'm going to say, here's a variable, here's its starting value. We'll do the same thing here. If you look at line 10, let me see something. Well, if you look at line 10, you can see I have a comma separated list of variable names. So in C, another thing you can do, if you need to create a list of variables and they all have the same data type, you only have to write the data type one time, and you just provide a comma separated list of names. So here's the data type. Everything on this line is a double. So I just created 1, 2, 3, 4, 5 variables with one instruction, right? And what do we say the semicolon means? That's how we terminate instructions in C. Here we're doing the same thing. I want to create some integer variables. Here is what I want to call the first one. Here is what I want to call the second one. Another thing we could do, if we wanted to, we could still do this with a list of variables. So here's a list. If I wanted to give some of these initial values, you would just write that as part of that variable name equals 2.0, right? This one equals 5.6. So that's perfectly fine, and see if you want to do that. Let's see, let's start with that section. So multi-line comments, // and an asterisk. Notice how everything below this turned orange. I've commented everything out below that line. All right, so, and then to end the multi-line, or to indicate the end of that multi-line comment section, you just put another asterisk and a // So that marks the end of my multi-line comment. This marks the beginning of my multi-line comment. So I just commented out this set of lines right here. So I don't have to do this on every single line. So let's take a look at what we have here, and we'll run it and see what it does. We're going to print the result of some functions and some variables here. So here we're going to call, here's my variable, right? So if we look up here, we can see I have a double called ceiling double. That's my variable name. Equal, what did we say the equal sign was in C? It's an assignment operator. And how does it work? It always behaves the same way. How does it work? How does the assignment operator work in C? Let's take someone on this side of the classroom. All right, let's call a volunteer. Let's pick, people with glasses are smart. We'll pick the guy in the black coat right here. So how does the assignment operator work in C? What does it do? What's that? It assigns, I'm sorry, it's hard to hear. It assigns, well, it assigns a value to a variable, right? We know that's what it does, but how does it work? Like, is the variable on the left or the right? Where's the information coming from? What is the flow of information? That's right. So what the assignment statement does is it accepts a value on the right and assigns it to a variable on the left. Very good. So here's our variable. Now this doesn't look like a value. This is a function, and we're going to learn more about functions next week. But functions are able to return values. Functions can return things. So when I execute this set of instructions, it's going to perform a calculation and it's going to give me back the answer. So even though this doesn't look like a value, this function returns a floating point number. And C understands that, so it will accept that function call in lieu of an actual hard-coded value. And it's going to execute this function, and whenever it returns that value, that's the value it's going to put into that variable. And this is the ceiling function. So for those that don't know what the ceiling is, if you take any floating point number, the ceiling of that number is just the next whole number. So 3.1, the ceiling of 3.1 is 4. The ceiling of 4.8 is 5. So take any floating point number, the ceiling is the next integer up. Floor is the opposite. So we're going to call floor here, and we'll save it in this variable. And floor will just take any floating point number and round down to the next whole number. Absolute value of a floating point number, and we'll just give it a negative number. So here we have, where's my double? Notice up here, we did give it a value, 3.2. Variables, numbers can be positive or negative. So we'll just pass it, I typed a minus in front of it to indicate a negative number, minus that variable, and it should return the absolute value of that, which is 3.2. Here, we're going to use mod for floating point numbers. So remember, if you want to use the modulus operation on floating point numbers, you have to use this function. The percent sign only works for whole numbers. It doesn't work for floating point numbers. If you want to do that, you have to call the function. And recall what we said, how we said that operation behaves. It takes one number, divides it by another number, and gives you back the remainder. So if you divide one number by another, instead of giving you the quotient, it returns the remainder. Regular division gives you the quotient. So in C, if you do division, you never get back both parts. You get back one or the other. You either get the quotient or you get the remainder. Modulus gives you back the remainder. And this is just going to raise, we saw this one earlier, right? The power function takes one number and raises it to some power. So we're going to raise 2 to the power of 8 here. And if we were to run it, you'll see it's going to just print the values out. So I'm going to execute these functions. They're going to return a value. I'm going to save it into these variables, and then I'm just going to print these variables here. Oh, I got someone in chat. Oh, sorry, I didn't have that open. Very good. Oh, I got an error. What did I do? So here, undefined reference to seal. Linux. Okay, give me one moment. You don't have to do this if you're on Windows. I have to do this. So this, we won't learn about this in this class. Remember, we said that the GUI is just buttons you can push and they substitute commands for you, so you don't have to know the commands yourself. When you're compiling C, it's not a program that has a GUI. A GUI just means a graphical user interface. So that compiler doesn't have one. It's a text-based program, so you type things. That's how you use it. JGrasp is a front end for that, where you push the button and it gives the command for you, so you don't have to know the command. Now, this is Linux. This is not something we'll cover, but just you know what that is. So this is some flag. If you want to use the math library, you have to give it the flag. Say, I want to use this library, and M is for math. I believe that's the appropriate thing. No, I still didn't do it right. I'm sorry. One moment. I should have checked this before I came. Flags are arguments. Let me see something. LM. Oh, I must have put it in the wrong place. That is the flag. Make. Let's just try to do it. Trying to do it here. All right, we're going to do it a different way. What did I call that? This is called main, and it's in selection. All right, so we just compiled it on the command line. Now, if I were to run it, So it created this executable file for me. Sorry, I don't have buttons to push. I'll fix JGrass later. I just don't want to take too much time playing with it. And we can run it. So when you click the run button, that's all it would do. It would just call that executable file for you. When you click the compile button, this is what JGrass does for you. It types that into the shell, sends that to the program. And we can see what we have here. The ceiling of 3.2 is 4, right? If we look at these side by side, if we look at these side by side, right, we can see ceiling. Here's our print statement. This is frustrating. I'm sorry. There we go. So what do we see here? The ceiling of, and here's our first format specifier, right? So it's a floating point number, it's a double, and I want to display up to 2 digits after decimal place, and I'm going to print this variable. And if we look, remember we made that variable up here, 3.2, and here we called the ceiling. So what is the ceiling of 3.2? Recall we said what the ceiling function does, rounds up. So the next whole number is going to be 4. We'll do the same thing for floor. So the next whole number below 3.2 is just going to be 3 if we round down. Here we call the floating point absolute value function. We gave it negative 3.2 and it returned 3.2, right? So and so on. So we can see the rest, right? 3.2 mod. Here's the string. I'm replacing these format specifiers with these variables. So 3.2 mod 2, if I divide it by 2, what's the result going to be? Well, 1.2 is the remainder, right? 2 goes into 3.2 one time, and there's 1.2 left, right? And here, raised 2 to the power of 8, you can see that run. If we wanted to do the same thing for, let's modify this again. We're going to comment these out now so we don't run all of these. Now we're going to do the same thing with the whole numbers. And we'll just do GCC again. And we can see the same thing again, right? So we had reload. We've got some whole numbers declared up here, absolute value of integer, division integer, etc. If we go down to the section, what do? We call these functions that were in the standard library. So here I'm going to call absolute value, pass it a negative number, and it should return a whole number, the absolute value of it. We're going to save it in that variable. We'll do that for all of these. Division, if you call the division function, you have to tell it which part of the division you want. You want the quotient or the remainder. If you use, if I do something like this, if you use the division operator, it's always going to give you back the quotient. If you call the division function, you have to specify whether you want the quotient or the remainder. while we're looking at this, here's another, let me cover another, let's call it a got you, that some of us will stumble on later. And this kind of question will show up on quizzes and exams. So I really don't want you, and I've had some people lose some points from homework assignments because of this problem here. So when you're doing integer division, C is very strict. If you divide one integer by another, it's not going to give you back a floating point number. So for example, 5 divided by 2 is not 2.5. If you save it as a whole number, 5 divided by 2 is 2 with a remainder of 3. So in C, if you were to do that, let's actually do that. Let's do that in JGRASP real quick. We don't need the math library for that. Let's open up another. That's a pretty important piece of information, and I always see people stumble on that. Come on, man. All right, let's do. All right. This is just so I can print stuff. So here, int x and y. We'll have two integers, and we'll do this with doubles to a and b. And let's give them some value. So here we'll do that example. X equals 5, y equals 2. This equals 5, but as a floating point number. This equals 2 as a floating point number. And let's just see what happens if we run these. That divided by that equals that. So x divided by y equals x divided by y. And so let's run this first one just so we can see what happens. And we run this, again, what we'll see when you're doing integer division, it just discards the floating point part of it. Because remember, we have in C, when you have variables, those variables have data type, and that is the only type of value you're allowed to represent. We can't represent floating point numbers with integers. That's not how they work. They only represent whole numbers. So when you do integer division, you lose the floating point part of it. If we were to do the same thing with the doubles, and here we'll just use A and B. Now here we can preserve that. These are floating point numbers, so we are able to preserve that part of it here. So 5 divided by 2 is 2.5, right? So that's fine. What if we tried to mix and match? So if we were to do, let's say this here, int answer equals A divided by 2. So I got a floating point number on the left and a whole number on the right. I guess I should do y, right? So remember, A is that variable, it's a double. Y is a whole number. Well, let's do this first, double. We'll do a couple of things. Anyway, x, y. So we're going to do a couple of things here. Answer 1, we're going to divide two whole numbers and save them into a double, because C will automatically convert numbers for you. But it may not always convert them like you think. So here we have two whole numbers. I'm going to do the division, and I want a floating point answer. I want 2.5, so I'm going to save it as a double. We'll see if that's going to get us the results that we want. Here, we'll mix and match. So we'll do x and b, right? So 5 and then 2.0. Oops. And then here, we'll make this an integer. And we'll do the same thing. We'll mix and match a whole number and a floating point number. So what we'll see if we were to just print the first one, this is the floating point number. It is going to print a floating point number, but it's not going to print. We still discarded the decimal part of it. Why was that? Well, we divided with two whole numbers. Even though I saved it into a floating point variables, originally I did whole number division. I divided two whole numbers by each other, and then I converted that answer to a double. So 2 converted to a double is 2.0. So that's what happened. I divided it, I got a whole number result, and then I saved it as a double. If we look at the second one, why don't we try to print the second one? Now we'll see that this time it does save it correctly. So again, we mentioned that C will automatically convert things for us. Right? I could have done this, right? We could have cast it to a double, but we didn't do that. The other thing you can do in C is, as long as one of these is a double, C will convert the other one to a double also. Right, so in C, when you're using these mathematical operators, you can't perform mathematical operations on different data types. It won't allow you to do that. Now you may think, wait a minute, I just did that here, right? Because that's a whole number and that's a floating point number, but actually we didn't. What happened was C automatically converted one to the other. So now we have two matching data types. So when I did this, when I gave this double here, C always converts things to the most expressive form. So you can express more unique values if you use a floating point number than you can with a whole number. So it converted this to a double. So actually we're doing double division here. It's B divided by 5.0. And C did that conversion for us. So now that we're doing double division, it's fine. We can save that floating point number in there. And finally, if we were to print the last one, we're going to attempt to do that conversion again, right? So we should get a floating point answer, but we're going to save it into an integer variable. And C will do that. It'll allow you to do that. Oh, what happened here? Oh, whoops. I printed it as a double. But once you print it, we can see that what it does, it discards that. So if you want to save, this is something you have to be careful with in C, right? Going between different data types and data loss. So this is an example of data loss here. I got a floating point number that's more precise than a whole number because I can represent things after the decimal place. But I save it into a less expressive data type. C is just going to discard the percent part. It's not going to round up or down. It's just going to throw away the percent part, and it's only going to keep the whole number. All right, so this is important. I know I spent a lot of time on that, but a lot of people will stumble here. So you have to be very careful with this. If you want to do, especially with division, if you want a floating point result, one of these operands needs to be a floating point number, number one, and you need to save it into a floating point variable. Sometimes you don't want to do floating point division. Sometimes you actually do want to throw away that decimal part. So in that case, you want to do integer division, or it's going to convert to a double for you. All right, let's see. Let's go back to the other file. Any questions so far? I know I've talked a lot today and I haven't given you all a chance to ask questions. Do you all have any questions? By the way, if you all ever have questions, please feel free to stop me in the middle of what I'm saying, and I'll try to answer your question. So I don't want this to be one way where I'm doing all the talking and you never have a chance to speak. So if you ever have a question, just stop me in the middle of what I'm saying, and I'll try my best to answer your question. Do the same thing here. And here at the bottom, let's uncomment all this. All we're doing is kind of demonstrating, I've already discussed it here, right? Where we have these variables, we're calling a function, and we're saving that result into that variable. We're going to do a lot of that later. But I just wanted to be a little more explicit in this part here, where I've just kind of spelled it out for you, right? So here I'm creating a brand new variable, and I'm assigning it a value. And instead of giving it a value, I'm actually calling a function for the value. So this could be a variable, this could be a function that returns a value, and that's okay in C, right? So we can, of course, so we run it now, we can see, right? Here are the values of all of our floating point variables after, you know, that the functions return. Here's the whole numbers, and we can see we kind of just did the same thing here, right? Called the function, saved the value, and printed the result. And with that, do we have any questions or any examples you want to see before class is over today? All right, Wednesday we'll do an exercise together, I believe. Let me see our schedule. Through the 25th. No, Wednesday we're going to start on functions. So Wednesday we're going to start on functions. And then what we'll try to start doing this starting next week, is we'll have one lecture day and one exercise day. So I'll talk one day, and the next day we'll do an exercise over that topic. And we'll try to, for the most part, that's the format of the rest of the semester. All right, have a good evening, everyone. I'll see you all on Wednesday.